Yes. Thank you for the introduction, and but of course I feel like home here because there is also Walid here, and we started together this workshop series, and there is Alexander, and then there is you, and there are many people and people from University of Oulu that could not attend, that were part of the community since the beginning. So it's very nice for me to have the opportunity here today to discuss with you the my recent research finding, because my main goal today is to try to discuss with you some recent findings that we could derive from some benchmarking studies. So for those who don't know me, I am Nicole Novielli, and I'm from the University of Bari, and I am an assistant professor there. And I am a member of the Collaborative Development Group, and we work on all human aspects in software engineering related to collaborative development. And my research in particular focuses on human aspects in software engineering. And my background is in affective computing and natural language processing. So that's why I naturally got interested in human aspects in software engineering. And I do my research in collaboration with people at Collab, which are Filippo Novielli and Fabio Calefato, who are both faculty members. Of course, we have PhD students, and Daniela Gerardi in particular is working on emotion detection using biometrics. And she just presented her study at ICSI on last Friday. So if you're interested in that other topic, which we will not be discussing today, please feel free to check your paper and ask your question. And of course, we are collaborating with also many visiting professors and researchers, and also Alexander is a lasting collaboration. And so I will be talking about what we found in our recent paper in many years, and you'll see that many of you at some point will get involved in the discussion. So what I work on, I work on both sentiment analysis, which is mining opinion and emotion from natural language. And recently I started working with Daniela Gerardi, which is the main person in charge of this research, as this is a PhD topic. We work on biometrics for emotion mining and cognitive state detection. And also David is a collaborator on this project. And so this is the vision we have in mind. We believe that emotional awareness in software engineering might be leveraged at different levels. At an individual level, can be used for regulating own behavior. So developer might find useful to identify, to become aware of the negative and positive emotion, so they can regulate their behavior and productivity accordingly. And at a team level, it is very useful. We believe it's very useful to be aware of each other emotion in order to improve collaboration dynamics. And of course, at the organizational level, the well-being and productivity are key factors to avoid undesired turnover or burnout and unsatisfaction of employees. So today I will be talking mainly about NLP and so sentiment analysis. And this is the project which lasted 3 years and was a trigger point for many collaborations. So here are some acknowledgements. As I already mentioned, we've been doing all this work together with other collaborators, and here you can see some of the names. And of course, some projects also were created as a spin-off of this project, which was mainly focusing on the role of emotion in question and answering, so in collaborative knowledge creation. But we've been doing also some work in social media in general, and also on biometrics, so using wearable devices to detect emotion. So just as a reference, the kind of guidelines that I will be deriving at the end of the talk can be found also in this paper. Going back to the topic of this talk, to label or not, why this topic? Over the years, having to deal with the problem of reliably recognizing emotion in the communication channels used by software developers, we came up with a lot of problems. First of all, we had to fine-tune sentiment analysis tools for the software engineering domain, and we will see why. And so this triggers another question. So do we need to label and use supervised approach, or do we need to rely on lexicon-based approaches so we can define heuristics which leverage sentiment dictionaries? So what's the idea? If we decide to retrain, what's the ideal size for the gold standard? And once we retrain, can we safely use these tools in another domain, in another platform, or we need to retrain again? So all this kind of question will be discussed in this talk. So if we are here, we all agree that sentiment analysis for software engineering is very useful in terms of actionable insights you can derive for improving software development practices. So for example, in terms of collaborative software development, emotion has been studying in correlation with issue fixing time, or to discover early burnout in open source contributors, or for anger detection towards peers and towards self, or for deriving empirically driven guidelines for question writing, as we did for Stack Overflow, for example. Another possible application has been the creation of recommender system based on opinion mining. And so what do developers think about some specific library, some specific piece of code? And again, another potential application, and Walid is also here, and requirements engineering can also leverage sentiment analysis to mine user opinion in their feedback in reviews, like positive opinion and negative opinion about apps and specific feature, or negative sentiment is usually observed when reporting bugs and so on. So I'm saying this here because at the very beginning of this research field, there was also some question coming from the reviewers. And of course, it was not very clear what could be the contribution of this kind of approaches to our field. So, and now I think that after several years that we've been discussing this topic, we can see that many actionable findings can be derived in order to inform good practices in software development and so on, and also to develop tools. So in very early stages, many studies use general purpose tools. And of course, this was very questionable because there are many problems related to the use of general purpose tool for sentiment analysis of the software engineering domain, because they've been validated on movie reviews, on tweets, on comments on YouTube. So those texts, they are not, they do not contain any technical lexicon, which is very specific of the software development domain and might have shift in semantics. So regardless of the approach, like NLTK and the Stanford classifier, they both supervise, while SentiStrength has lexicon. So it basically implements a set of rules which rely on the identification of lexical cues for positive and negative emotion by looking at a dictionary. So regardless of the approach, these tools had problems because as found in one of the study reporting negative results, they have poor performance on technical text. They disagree with each other, and this disagreement, of course, can lead to diverging conclusion when you're using sentiment analysis tool for running empirical study in software engineering. And in search for an explanation of why do these tools fail, we perform a manual investigation of about 800 question answering comments from Stack Overflow, and we found that the main cause for example, in our case, the main cause for misclassification was that most neutral cases were classified as negative. And this was due, for example, for the inability of the tools, and back then we used SentiStrength, for example, but it could be any, of the inability of dealing with the contextual semantics. So I'm missing a parenthesis, so I'm not saying anything related to missing somebody in a relationship. So it's just a technical context. So this term should be labeled as neutral. And again, platform-specific use of non-neutral lexicon can also misclassify. Like if I say I have a problem, please explain me what is wrong. I'm not saying anything negative. I'm just reporting a problem. And the context, which is Stack Overflow in this case, is of course what should be influence the decision, because people are supposed to go on Stack Overflow to discuss problem. So we have to be aware of the fact that there is a general tendency of observing more frequently lexicon expressing problem of something that goes wrong. And finally, there is also a problem related to domain-dependent semantics. So what is the best way to kill a critical process is something which simply means that we want to terminate the process. But this is usually perceived as a negative sentiment word, so is mislabeled as negative. So to go further, deeper in this direction, we also trained some vector space for those who are not familiar with this. So you can basically leverage tools such as Word2Vec or Glove by Stanford. Word2Vec is by Google, but there are many out there. What you can do, you have a large collection of document. So for example, we did this using 20 million posts extracted from Stack Overflow. They're unlabeled. You don't have any additional information regarding to the sentiment. So you just use this huge collection of document to train a distributional semantic model, which is basically a vector space. And in this space, you can compare words and you can compare documents and word and documents using cosine similarity. So words that are closer to each other share the same semantics. And you can also create ranks, like you can have a target word and you can see what are the closest words to this target word. So we play a little bit with three different semantic spaces, and one was trained on Stack Overflow, and the other one on the English abstract of Wikipedia, and the third one on 15 million tweets. And we found that, of course, like, let's see this kill as a target word. The top neighbor in the space, so the vector who are closer to the vector for the word kill, in Stack Overflow are mainly neutral. So you can see that it means to suspend, to quit, to exit, to shut down a process. But if you look at the Wikipedia abstract, you can find synonyms such as decapitate, assassinate, kidnap, destroy. So the shift due to the context to the domain here is pretty evident. And it's the same for positive words such as save, which simply making something persistent. So you can see in Stack Overflow you have store, resave, persist as synonyms, while you have protect, recover, resurrect in Wikipedia, and the same in Twitters. So there's definitely need for domain-specific tools. And trying to overcome this limitation posed by general purpose tool, researchers started to develop their own software engineering specific tools for sentiment analysis. And two approaches mainly prevailed. So the first one was about developing classifiers based on supervised learning. And the second one was leveraging lexicons, which is collection of documents and a set of heuristics to look up this dictionary and to identify positive, negative word in the input sentence. And in particular, SentiStrength, SC, and DEVA are developed on top of SentiStrength. So they leveraged an adjusted version of the original general purpose tool. And Center for SD in particular was developed at Collab. So we developed this polarity classifier tool in combination with an emotion mining toolkit. And here is the first distinction, which we will be discussing further in detail later. So on one hand, you can classify polarity of sentiments, so positive, negative, neutral. And on the other hand, you can also look for, as in the study from the colleague from Oulu that was presented this morning, you can also look up for specific emotions such as joy, anger, fear, surprise. So you were looking for specific labels, so discrete emotion labeling. And in our toolkit, we have both. We have a tool which is for polarity, which is Center for SD, and then we have an emotion mining tool. And both tools can be retrained and can be customized, because you can have your own data set, you can have your own gold standard with the general purpose. We replaced using your own specific sentiment lexicon. Like, for example, we did with colleagues at the University of Oulu, we used the lexicon for emotional arousal using software engineering data. And the tool leverages supervised learning, as I was saying, and it has mainly three feature sets: keywords, which is union bigram; semantic feature, which is the representation of document in the semantic distributional space, as I was saying; and sentiment lexicon are also used to identify positive, negative words. And indeed, we observed that we were able to reduce the negative bias, which I was discussing, strength. So comparing with the sentiment-strength baseline, we can see that the precision for negative and the recall for neutral improves as a result of the correct classification of neutral cases as neutral and negative cases as negative. And so, for example, as per your code, classified by sentiment-strength as negative, but it's correctly classified by Senti4SD as neutral. And other than this, we were able to reduce strong disagreement, which is disagreement you don't want to happen because you're confusing positive and negative polarity. So this happened more frequently with general purpose tool, and we were able to reduce the occurrences of this kind of disagreement to less than 3%, so 2.4 in particular, at least on our validation set. So in our case, we observed this, we had a successful experience with Stack Overflow data and supervised machine learning, but the question here is that does software engineering specific tuning represent a silver bullet for enhancing performance of sentiment analysis in software engineering? So trying to answering this question, we ran a benchmarking study and we compared the performance of the 3 tools that were available at the time. And we had 2 supervised tools. So our tool, CentiCR, which leverages unigram and bigram. So Bagel was featured using supervised training as well. And that was originally trained on code reviews. And Senti-Strength SC, that is a lexicon-based tool, as I was saying. And what we did, we took the original study and by Alexander and colleagues, and we, which was reporting negative emotion of general purpose tools. And this is the set of tools they were evaluated. So NLTK, Stanford NLP, Alchemy, and Senti-Strength. And we repeated the same evaluation. We could get the tool. Can you? Okay, I hope you can see me. I was notified that probably my connection had some issues. Okay, I will continue for now. So please let me know if you don't hear me or there is any trouble with my connection. So as gold standard, and we use Senti-Strength as a baseline. So as a gold standard, we use 3 data sets from different platforms. So we had 2 different data sets from Jira and 1 to Stack Overflow. What we did, we used 70% of each data set to retrain the supervised tool, and we evaluated all the tools on the remaining 30%. For the sake of comparison. So we use the same portion of the whole held out test set for comparing the tool. And in order to assess the performance, we evaluated the performance using traditional precision recall and F-measure metrics, but also using weighted kappa because we wanted to has more severe, as strong the disagreement between positive and negative. So we assign double the weight of disagreement between neutral and positive or neutral and negative. So to answer our question, so do a software engineering specific sentiment analysis tool agree with gold label provided by manually labeling data? Then the answer is that we observe a huge improvement from the fair agreement for the general purpose tool to a substantial agreement observed for the software engineering specific tool. So the answer is that yes, software engineering specific tuning is able to improve performance in the software engineering domain. Furthermore, software engineering specific optimization also improved precision recall and F measure and the agreement between the tools, which is significantly improved. As you can see from here, we go from less chance to fair agreement in general purpose tool to much improved situation for software engineering specific tools that have an agreement from substantial to almost perfect. So to answer your question, software engineering specific tuning enhances sentiment analysis, so it is recommended. So do not, the general recommendation here is to not use off-the-shelf tools which have been been talking about in general about polarity. So, but polarity can be about opinion, can be about emotion, can be about attitude. I might show a negative or hostile behavior towards peer in an online discussion. I might demonstrate I have a negative opinion regarding a specific API or a specific implemented solution. So all these different affect opinion, emotion can be either positive or negative. And in absence of those, we have neutral polarity. So, but do we really need this kind of distinction? Do we really need to an affect more, a model of affect? Well, if we were in the same room, I would ask you, so please get your phone ready. So if you want to participate in a small poll. So in this case, for example, I'm happy with the approach and the code looks good. It's pretty clear it's positive. So there's no doubt that somebody is expressing appreciation toward a piece of code. And in this case, these are all real examples coming from our data sets. So, and I will come to your work in SLAPU, it's clear sign of negative behavior. However, if we look at this, so if you want to participate in this pool, do you see the, I guess you see the survey results here. Just take a picture of the QR code and you can vote whether you think this is positive, negative, or neutral. I don't know if it's visible. No, it doesn't seem to be visible.
It's working for me.
Oh, it's working? Okay, but I don't see it updated. Oh, yes, I can see it. So someone saying is neutral. Somebody says negative. Oh, cool, it's working. I mean, okay, so of course nobody is saying this is positive, but some of you say it's negative, some of you say it's neutral, and probably those who say it's neutral is because they have emotion in mind. So this person is simply saying something which is objectively negative. So this code has problem, and which means that, oh, just a sec. So which means that we are talking about a polar fact, something which is inherently negative. So you don't want code to have problem. So, but some of you think this is negative per se, so it should be labeled as negative. Some of you think this should be neutral because nobody is saying something nasty at another person. So what about this? Can you see the poll?
Yes.
So this is not ideal. Why not trying to find another solution? Please vote. Okay. Okay. Oh, even positive. Mm-hmm. Let's wait a little bit more to see whether the situation changes. Well, positive is surprising. I didn't expect this. Okay, so you think it's mostly neutral. So this, it seems like you don't care about your peer opinion. So okay, there are some negative votes. Okay, good. So again, and this is due to the fact that you have something conceptualization of affect in mind. Some of you think about opinion, some of you think about emotion. So probably those who were thinking about an opinion, like I'm expressing a negative evaluation of this piece of code, probably voted this as negative. I don't understand the positive. I will ask you in the question answer who thinks this is positive. And so again, opinion is different from emotion. I don't want to go into much detail for this, but just to give you an idea of the huge variety of possible affective states that psychologists try to define in their research. So they range from personality traits to emotion and passing through interpersonal stances, which is whether I'm behaving in a friendly or hostile manner, moods, so which is long-lasting with respect to emotion, and attitudes, whether I do like or I hate something, so which is kind of related to the concept of opinions. And so it's really a plethora of different conceptualization of affective states. But the problem here is that, do we need a theoretical model of affect when doing sentiment analysis in software engineering research? So trying to answer this question, we compare the results that we got with the previous data set, which were obtained using model-driven annotation, which means that people were explicitly told to label emotions in this specific case. So they were provided with a taxonomy of emotion, and with clear guideline of what is an emotion and what is not, and neutral was provided only in absence of any emotion. And in the second case, we had another couple of data sets which were labeled using ad hoc annotation. So people, they were simply providing labels of positive, negative, or neutral sentiment based on their subjective perception. So without any specific reference to a theoretical model of emotion. So in our cases, for example, we even provided some clear mapping between positive and negative emotion. So we say this is positive, this is negative, and the macro labels for positive, negative emotion were associated to second or third level finer grained label to provide exact guidance to the labelers. So we compare the results we got with on model-driven data sets. So we did exactly the same approach that I said before. So we retrain and test. And we observed that on model-driven annotation, the performance is significantly better than what we can see in ad hoc annotation. Because of course, in ad hoc annotation, you don't have a clear reference to a theoretical model of affect. So all the disagreement that we have seen in these polls, it actually is, it is transferred into the training phase, which is, so the gold standard is much more noisy, and this impairs the training of the classifier. And of course, the kappa reflects the same situation, and you can see there is much lower agreement for tools, for the very same tool, when they are trained on a gold standard, which is labeled using ad hoc annotation, so without explicit reference to the theoretical model of affect. And indeed, we did a manual investigation of the analysis of the causes for error, and we see that the polar facts, as we were discussing so far, like I tried the following and it returns nothing, so, which is inherently something negative that you don't want to happen when you're coding, but it is, lexically speaking, it is neutral. So these kind of examples, which we called polar fact, are the most frequent cause of misclassification in our experiment, in our benchmarking study. And it is mainly relevant for this yellow one is the Java library, which was labeled using ad hoc annotation, so without any theoretical model of affect. And the same here for the code review, which was labeled using the same approach. So the answer is yes, we do need a theoretical model of affect, and of course we need to pick this model of affect according to our research goal. So if you have in mind community moderation, you want to look for hostile behavior, for hate speech, and all these kind of lexicons, which specifically identify the fact that people are behaving, are violating code of conduct, for example. But if you're looking for, I don't know, opinion, you don't necessarily want to discover emotion. You just want to know whether people are satisfied of when using a library, when using an app, when using a specific framework of technology. So you might want to look for emotion. So this really depends on your specific goal. So third and last question. So reliable sentiment analysis in software engineering is possible provided that you retrain and you have a theoretical model of affect. Does this mean that we can use software engineering tools that are now available off the shelf. So without retraining, we just take them and use them on our data. So we repeat the same study in a cross-platform setting, which means that we train on one platform and we test on another platform to see if any drop in performance is observed. So it's a kind of like domain adaptation experiment, but by differentiating by platforms. So, and in particular, we use the model-driven annotation datasets taken from Jira and Stack Overflow, and we developed the third one of about 7,000 comments from GitHub, which you can download and it's available. And what we did, we train on a platform and we test on the other one. And of course, on the diagonal, you can see the within platform setting, which we are reporting here. I'm reporting here for comparison. So as you can see, the situation change. We have very good performance for within class platform training. So if you train and test on the same platform, you have pretty good performance like 0.392 F1 or 0.82 for CR, but there is a drop of about like from 12 to 30% in performance when you test on a different platform. So on the 30% of test set from another platform. And of course, this might be due to the shift in the lexical semantic across platform, because there is some specific jargon which is used within a specific platform and which is perceived in a specific way by the user of a given community. And probably, and since this is observed for all the combination of platforms, this probably suggests that we need to narrow down the concept of domain at the level of the specific data set of the specific platform. And we also observe, just a sec. Okay, we also observe the highest drop when the Jira dataset is used for training, which might be an indication of the higher distance of the Jira gold standard from the other two, and which can be explained in several ways. So for example, this can be explained in terms of different label distribution. So Stack Overflow and GitHub have similar label distribution, which of course causes a more robust training, while you can have a bias towards the majority class when you have such an imbalanced data set, and as in the case of Jira, for example. And also another thing that we observed is that we have far better agreement on the two data set built from Stack Overflow and GitHub. And since the drop in performance was lower, was higher when we use Jira as a training set, probably this is also an indication that also the robustness of the gold standard is also affected by the annotation, the inter-rater annotation agreement. So, and if you cannot retrain, you can always use lexicon-based tools whose performance are comparable. So, of course, in a within platform setting is always more convenient to retrain. So below you can see there is the performance of sentence strength and data who are based on lexicon, so they cannot be retrained. But if you look at the cross-platform setting, in a couple of times, in 2 settings out of 3, you have better performance with the lexicon-based tools, which tend to be to perform a little bit better with respect to cross-platform training testing. So the answer to this question is maybe, it depends. It's always recommended to perform a sanity check, first of all, because you want to know whether they perform well according to manual labeling, and whether what the tools actually produce as an output is what you're really looking for, whether because the tools can be designed to identify opinions, but you're actually looking for emotion and vice versa. So provided that relabeling, especially in a within platform setting, is always convenient, apparently, let's see if this is true. So if we can simply reuse lexicon-based approaches, or we need to relabel. This is a relevant question because labeling data is a great effort. So it's very time consuming. It's not always easy to agree on the taxonomy. So it's a task which is very, very demanding in terms of time and effort. So we retrained in search for an answer to this question. So how many data do we need to reliably retrain a classifier? given that we have a new target platform for which there is no available gold standard? So, and the answer is that for what we did, we plot the learning curves by using incremental training set by adding 5% more at each time. And we always test on the same 30% partition that we've been using so far. And we showed that retraining is convenient for GitHub and Stack Overflow. We have this agreement in the results, and retraining is convenient compared to the performance of lexicon-based tools, which is the straight line, so it never changes because of course they cannot be retrained. And nearly optimal performance is obtained with a minimal sets of about 1,200 documents for both datasets. The situation is different from the Jira data for the Jira dataset, where retraining is beneficial only if a larger dataset is available, and even Smoky doesn't help here, so it's not only a problem of balancing, but it could also be due to the fact of the agreement, or it could be also due to the fact that scientist strength SE is hard to beat as a baseline, as a reference performance, because it was actually specifically fine-tuned using a subset of the Jira dataset. So it's very optimized for that specific domain. So to wrap up, to conclude, so based on our experience with benchmarking tools and developing gold standards dataset, we have some lessons that we learned that we would like to share with you for safe and reliable sentiment analysis in software engineering domain. So the first advice is to use software engineering specific tool, because regardless of the general purpose one, they tend to achieve better performance with respect to those trained with outside the domain of software development. And the second recommendation is to use training data. If you decide to retrain, to use training data from your target platform, as performance might be affected by platform-specific jargon and semantic shift due to the way to communication convention and styles which are adopted within a community. And also the gold standard has to be robust, which means well-balanced in terms of polarity classes distribution, and you have to achieve good inter-rater agreement. So you have to be sure that your annotation schema is reliable, whatever it is, regardless of the fact that you're labeling emotion or opinions or hate speech and so on. And if you cannot retrain, perform a sanity check, because of course you want to be sure that what the tool producing output is what you're actually looking for in your study. In order to do so, you need to define your goal first. So you have to decide whether you're looking for opinion, emotion, and why you need this kind of information. For what kind of actionable findings you need this analysis. And of course, the choice depends on the research goal that you have. And this is basically it. So I'm happy to take your question. Thank you.